We live? Okay. I think we're live. We are. All right. So what I'm trying to get done today. Let's get a new window going. What I'm trying to do today is we have a midterm due in about 2 weeks that we essentially need to let's see, develop self-organizing cluster tree network. Essentially the first step is we need to make mesh routing. I have done that. Then the next step is to there's some report and data gathering, which I'm gonna hold off on for now because that's kind of, I feel like that's kind of last step is to gather those metrics. I've gathered some, but that's besides the point. So these config parameters I do have set. So I'm gonna say that is all done. And then I'll just add here that a comment that implemented, but logic needs to be added for network to be stable with these parameters. Okay. Okay, what else is there? Cluster overlap reduction. As I mentioned, this is the hardest. What I want to do for this is I have my variation here, cluster overlap reduction. What I want to do is clusters overlap minimally, cluster heads communicate via a router. So I want to add this router, and I have made it a role already in, where is it? So we have this router role, and I've just recently added that, like, this is just a specific color that will make it, and I guess we'll have a transmission range. Okay. But I think for now, for the sake of this, I want to not allow 1 for smart choice, 0 for default across all. Okay. Now, maybe I can run this and show what currently goes on. So we have a ton of clusters here. Everything that's blue, every node that's blue is a cluster. And I think I can check what each one is. So we can actually see how many cluster heads there are. There are 56 cluster heads across 100 nodes. That's actually some good data. Let me add that to some ongoing metrics. Ongoing metrics. What seed are we using for this again? Seed 1. Okay. Ongoing metrics. Base implementation makes 56 clusters. Let's try to minimize this. And I think in turn, by doing that, doesn't it say clusters overlap minimally? I think what we can do instead is kind of cluster overlap heavily because new cluster heads are chosen from within existing clusters. True. This is very true. That's kind of how that works. I think what we want to do first is just have a... So first of all, I kind of want to step through this. Let's do set roles dot cluster head. Okay. So we have a network reply and a cluster head address is none. Okay, so we want this one. We want a breakpoint here every time. We want to see every cluster head get made and see like what is not efficient. That's kind of what I want to walk through, at least to start. All right, so let's run this in debug. I gotta figure out the shortcut for that. Okay, let's pull up the topology. Why are there two? This one looks cooler. All right, we can see that plenty fine. All right. Okay, so first cluster gets formed with that node 16. Makes sense. Ah, damn it. That's really annoying. Okay. I'm gonna split screen this for now. Yeah, it still works. We just want to see the behavior. Alright. We got another. Node 26. And even that node is not that necessary. Although, I guess, because it comes online, so immediately I see why we would need to transfer roles, because now 25 and 26 are going to become cluster heads, but they're so close together that that almost seems unnecessary. It seems like maybe you would need 25, but then I think ultimately you swap 26 from being a cluster head to maybe even, I don't know what node this is, but whatever node's here being whatever node is here being registered. But okay, let's continue on. What I want to see is a cluster, I want to see a cluster here, a cluster here, and then instead of making a cluster in between those to communicate, making a router instead. That's what I want to see. So I think 25 is a perfect, okay. So try to minimize overlap. which means in turn, where's my scratch pad? Hello? Okay. Okay. To minimize cluster overlap, we just want to minimize the number of cluster heads that other cluster heads observe as their neighbors. If that makes sense. Right now, how do I explain that? So these two are cluster heads, but they have a ton of overlap. Let's bring out paint. My thinking is we have a registered node. Let's say we have a registered node and it's talking to another cluster head. Can we simply do a check in our neighbors table? So let's think this through. Let's bring out paint, shall we? Okay. So is that showing up? Oh yeah, cool. Okay. So my thinking is if we have a cluster here and then we have a cluster here and there's like a registered node here that is, let's just say for the sake of the argument, it can reach both. We don't want the clusters to have to like route all the way around to each other if there's a gateway right here. So my thinking is that if two or more CHs in neighbor table become router. Now, this comes with one assumption. The one assumption I want to make is routers stay as registered nodes to their originating cluster. That means their addressing stays the same, but this might change. I'm trying to think. This might not change the logic that much. I'm bald. Anyways. Okay. So with that in mind, where's our router one? That's what I want to see. If we're registered, let me think about this. Check to see if we have two cluster heads present in our neighbor table. Now, I first want to log our self dot neighbor table. And I think originally it should only be one hop. Immediate neighbors. Okay. I'm gonna save this and start over. Alright. I'm moving this off the screen for now because it's annoying me stepping through it. Okay. Let's run. Roll as root. Roll as root. Okay, so it has roll in there. So we would do if for n in self dot neighbor table, and we'll make this a function, but I just want to keep it here for now. We'll make it check to become router. Okay. For n in self dot neighbors table, if let's keep a count. Ch count equals 0. If n roll equals rolls dot cluster head, then we increment our ch count. If ch count is greater than or equal to 2, then we do self dot become router. So now we can kind of just substitute this with self dot check to become router, and we will take this logic and put it in a function up here. Let's first look at become router. Become router. For now, let's just keep it at that. Let's not do anything crazy. Let's just become a router. I hate how that happens. Okay. We want def check to become router. Let's shift I like this. This might slow things down, but let's see if it actually works. So we want a breakpoint there, and then where's our other breakpoint? We had a really stupid breakpoint that was really going to slow us down. Is it here? Yeah, it was. I don't need to log our neighbor's table anymore. And let's run it. Hello? Whoa. In object is not subscriptable. Hang on. Why did I think that would be fine? Is that neighbor table a dictionary? Oh, wrong thing. Check on it's registered. Neighbor table is a dictionary. Okay. So I hope we're back. We're back. OBS crashed. Why is it going all the way up there? I just want to see. Alright, I'll look this up on the side. Okay. It iterates over the keys. Okay. Okay. So we just want the neighbor table dot values. That's all we want. Ain't nothing but. Alright. Let's run it again. Let's go. What just happened? Okay. Is there a hotkey for it? Oh, it's F5. Damn, I can't do that. Alright. I just kind of want to go through this and see if anything becomes a router. Okay. That one actually, okay, so this one actually makes sense. This one can make sense. So honestly, right now, I don't really care if this converges. I just want to see if the number of cluster heads that get created is less, and significantly less is kind of my goal. So we'll just keep stepping through. Now we need to fix some logic. The edges have too many routers, but if we close out this session, is 15 actually undiscovered? There are a lot of undiscovered nodes, but there's not that many. So maybe let's just stop it, and then we will let's just run it as normal. Where's the run button? There it is. Okay. Obviously, there's some problems, but like that's a lot of unregistered nodes. Let's actually count how many were unregistered. 22. Therefore, there will be less cluster heads, right? 38. We're cracked. Okay. Obviously, we need to change the logic for how a node joins a cluster, because right now it gets fixated on one. So I think the select and join but we don't want the min. Okay. We need to change this how. Right now, this will keep choosing the same neighbor or the same cluster every time. Candidate parents table is just a list, right? Okay. Changing that to a dictionary is kind of a lot of work. Oh, but we're doing a list of packets. Why do we do that? Oh, that's annoying. Okay. I think we want to do a self dot join request attempts equals of our min-hop GUI equals I need chat for the logic on this. All right. This is what I want, I guess. And then we'll make this a dictionary. In our init. Okay. And then we'll make a self dot join jr threshold equals 5. So my thinking here is if we have check to become router, but that's not what we're working on. Select and join. If self.join request attempts of min hop GUI is greater than self.join request threshold, we need to choose another node. All right, I will be right back. I'm gonna grab some tea. So, be back in a few. Okay. We are back. Where's my shit? There it is. Alright. Okay. So we probably want to put this in the loop. Let's see how this works. So let's walk this through. We select and join, we go through a candidate's parent table. If we are less than or equal to our if we're less than our threshold, then we will choose that to send. And if not, we'll skip. How many does it send? How many? How? What? Send, join, request. Wait, I'm so confused. So where's the key error? Oh! Okay. Is this the same topology? How many? 38. And wasn't it like 22 unregistered? Damn it. So it's the same. Okay. Let's go through. Let's go through this every time and see what we're at. Where's our thingy? Alright. So sure. 17, obviously got nothing. Okay. Min hop, 99, round 16. We continue. It's node 25. Oh, I'm stupid. Of course this isn't going to change our logic yet. Okay. It's always going to be your min hop GUI here. So let's go back to the drawing board here. Okay. So I kind of just want to see this logic. Okay. On node 36. Is that one? We want to join 26. Sure. Min hop equals 2. Okay. That makes sense. Let's step through again. Let's step through now. So for node 35, it has 25, and it's tried it once. Candidate parents table. We have 25 and 36. Okay. Then node 46 wants to join 36. Does that make sense? It does. But its candidate's parent table is only that. So we're back to 35. It chooses 25 again. Okay. 35. Its candidate's parent table is now 3 long. But, okay. It's based on minimizing hops. I want to get back to node 35. Yeah. Join request attempts. It's only tried to join its min hop neighbor at 25, but 25 is a router. In its candidates, it has 25, 36, and 46 as possible ones to join. I'm kind of, how has it not become a router? Oh. Because I haven't heard a heartbeat. Are these timestamped? They are. Okay. I'm just gonna look up how to update this really quick. So I don't want to always append to it. I want to update it as well. All right. Thank you, chat, for this one. That will help. Okay, let's run it again. Okay. $35. Okay, that's huge. Let's think through this. attempts equals self dot join request attempts dot get the global unique ID or 0. If attempts is greater than or equal to self dot JR threshold, then this is where we would want to just continue, and we update otherwise. I think everything here will work. Let's start this over and run. I want 35 to try another node. Is that 3 attempts? Okay. It's at 4. Okay. That's what I wanted. And it becomes a cluster head, or it becomes a router. What happened? Where are we stuck? Where are we? Where are we stuck? Why did it freeze? Hang on. I think I held... That was scary. Okay. Let's just run it as normal. See what happens. Oh, it's just a key error? For what node? Node 5. Okay, so we need the logic in a router to become a cluster head if it hears enough join requests. Unregistered. I think we can just do this. I guess we'll try it. It is so slow. Oh, well, hang on. I know one thing right away. If self dot roll equals roles dot registered, then we check. Yeah, I'm stupid. I was checking that every time. What's funny is everything that's not okay. Unregistered nodes. Where's that again? Yeah, where was that printout? Unregistered nodes. We're checking roles.router. Okay. Okay. And then what is our topology? Is that the same number? 56. And then everything else became okay. So I'm gonna stop there, but I mean, so now we have the router itself. It's just not router role present wrong nodes becoming routers, not minimizing cluster overlap. Cool. All right.